we were seeing that the enterprise routers are very expensive, and these routers, enterprise routers, also actually have their interfaces. Okay. So, the interface is how we are going to interact with the router device. Okay. And if you remember during our demo of SNOT, we were having most of command line interface. Okay. So, for example, when we were configuring SNOT, we were actually using the CLI of SNOT, saying that SNOT -a console and all those things. If you want, I mean, you can get a nice GUI for SNOT. I mean, either you write it or you can get it from open source. Similarly, okay, all these routers, okay, can have a CLI interface, command line interface. Cisco routers have it, okay, the Juniper routers have it, okay, and the command line interface of Huawei routers sometimes resembles Cisco's routers due to certain reasons. Okay. Then what we can do is we will look at Telnet and SSH, okay, SNMP. These are all the ways by which you actually interact with your router. Sometimes these configuration interfaces could be proprietary. Okay, Cisco could give their own tools, and there is something in a Cisco Works Management Center. So, the network management console and things like that. So, these GUI actually make the life of the administrator slightly more easy. But if you are looking at convenience and you are an administrator, usually CLI scripts are much more faster and efficient to execute, because GUI usually takes some time. The other thing is that these routers will also allow you to do some sort of central management, okay, and it will be, you can have a huge console in front of you looking at the network, where there are a lot of routers and then each of them sending some status and all that. It will look like a space shuttle launch pad. I mean, you can have a network operations center, they call it as a network operations center, and this is where they actually use these kind of software and then monitor the whole network, which includes intrusion detection, prevention, how firewalls work, and are they getting any alerts, or are you exceeding some bandwidth, etc., etc., etc. So, the examples of some of these enterprise routers include Cisco ASA series or Juniper J series. So, usually, I mean, you buy the enterprises have their own method of buying their routers. So, we are not specifying that you have to use this router or something. So, in our case, for example, we will use some of Cisco's ASA's routers for some kind of demos. Okay. And if you look at consumer grade routers, you have Linksys D-Link, and sometimes you can also use your custom routers. Okay. Okay, sometimes the person, the ISP itself will provide you the router. Okay, but then be cautious about this, because you do not know what goes inside that router. There could be some kind of backdoors, etc. One of the stuff that you could look at is, I mean, is there any extra data that goes out of the port? I mean, this is a small test you could do. You connect two networks routers together, okay, inside, and then within your own network send data from one network to another network, and then see whether you are getting any data out of any other ports. Okay. This small test will help you find out whether data is getting leaked, etc. Anyway, so coming to capabilities, the consumer grade routers, they provide connection to ISP via PPP over Ethernet, okay, and they have DHCP, NAT, 802.11 wireless interface, okay, they have port filtering, they have MAC address based filtering. See, if you are using your home router, okay, it is always a good idea that even though you might give DHCP and all that, our suggestion, if you want more security, is that you put filtering based on MAC address. That means record all the MAC addresses of the device that you use in your network, okay, and then allow data to flow only from those devices with those MAC addresses. Okay. So, in that way you will be having a extra round of security in your house itself. Otherwise, if you are going to use DHCP, it is totally unsecure. Anyone can, if your network, someone attacks your networks and opens it up, and they will get connected. Okay. Many of these consumer grade routers provide a web interface, because as I told you, in enterprise networks, people would really be certified, and so they will be some sort of geeks. So, they do not prefer GUI kind of stuff, whereas in a consumer grade routers which is used in your homes, you would rather go with a nice GUI setup, so that it is easy for you to configure. You could also make your own router. Okay. So, sometimes it is needed for forensic experts. See, when I do not trust the router, I say let us assume that I found out that one of the routers has been compromised. Okay. Now, I want to really find out whether that router has been compromised, okay, by an attacker. So, what could I do is I could replicate the configuration of that router into my Linux based say a router, that is my own router, replace that router and then see whether there are any differences in behavior between the previous router that was there and my router that I have put. Okay, because if I had strengthened my router and then things are working fine, and you know that the other router is misbehaving, then you could actually identify there is some kind of compromise that would have happened. Okay. So, under such circumstances it is better, and plus your own router you could also put get the logs and then get whatever logs you want, because sometimes if it is company specific then there are certain restrictions. Okay. The advantage of using the Zebra software based routers is that it uses Linux base, and then there is very good protocol support. Okay. It supports protocols such as BGP, RIP version 1, RIP version 2, etc. I believe there is also MPLS support. So, these are but you might need a fairly powerful box if you are going to deploy it in a large scale, but if you are debugging at an enterprise level, I think you have enough systems which can provide you support. Okay. You could use one or more of these routers and then get the data that you want to have. These routers also have IP tables for filtering. We will take a look at IP tables firewalls in next few sessions. And the advantage of make your own router is that you can bring about your own logging mechanisms. Okay. So, as forensic experts we need lot of logging to happen. So, now looking at routers, what are all the evidences that one can get from a router? So, first is the volatile evidences. As usual you could get the routing tables. There is lot of statistics that routers throw out, including bandwidth, and then if you look at the Cisco's show command, it will tell you what kind of statistics a router can dump, right from the virtual memory, the number of processes that are running in the router, etc., etc., etc. Then as usual you can get the ARP table, you can get the DHCP lease assignments, you can get the access control list, you can get the running configuration of the router. Okay. You can get lot of flow data and statistics. In fact, some coarse and fine grained statistics can be got from the routers, and also the IO and processor memory utilization, because sometimes if some computation kind of stuff is running inside the router, okay, you will see that there is high processor and memory utilization, and you can try to find out what is happening. Okay. So, these are all the volatile evidences. As far as the non-volatile evidences in a router is concerned, you could look at the OS image, okay, then the bootloader that is being used, then what are all the stored configuration. Previously we had running configuration, we can also look at stored configuration, you can look at access log, and then you can look at the DHCP logs. The other way is that, okay, now this is if you have the router in your hand. Suppose what happens if you go for remote access, then most of the evidences will come from syslog of the router. So, you might have to log into the router and then get all these data, okay, DHCP log, backup configuration, flow data, etc. So, you can log in and get these data. Now, after routers, the next device that we will be using, I think we had seen enough of firewalls in one of the sections, but we will now look at what is the forensic evidence it provides, and especially we will take a look at IP tables, okay, which is available in Linux. So, we will also see some demos of how to configure filters in using IP tables. Okay. So, in that case, so we need to have some kind of theory before we go into that. Okay. So, one of the things with firewalls is that you could have both hardware and software based firewalls. okay, and firewalls actually provide you a lot of information, okay, and they provide whether someone has tried to connect to your network, okay, and whether the connection has passed, whether the connection has failed. Then it also talks about the protocols that are being used for communication, okay, and it also has bunch of on what are the applications that are, because there is something known as application level firewalls, okay. So this tells you what all the applications that are passing through these firewalls, etc. Okay. As far as the configuration of a firewall is concerned, okay, so we will, it is similar to what, so it provides a kind of what a protection, okay. Therefore, it sees something known as an internal network which it wants to protect, then it has something known as an external network it wants to protect, and there is something known as demilitarized zone where it wants to protect this between the internal and the external network. So, a firewall actually does this job, okay. So, if a firewall is compromised, I think the whole security of your organization could be very well compromised, okay. Because of this security issue, it is configurable to get more and more data from firewalls, okay. There are different types of firewalls, okay. The first one is packet filters, okay, like which allow or deny packets, okay. So, we will see an example of IP tables which we will configure for allowing or denying packets. Then there is this session layer proxies, okay. So, essentially what happens is that if instead of a source connecting to a destination on the internet straight through the routers, they actually, it is a sort of man in the middle, okay. This proxies sit in the middle, and then the connection comes to this proxy, then the proxy redirects the connection to the destination, okay. So, the source establishes connection with the proxy, and then the destination establishes connection with the proxy, and then it is the firewall, okay, that sits in between these two guys, and then it does SSL connections. I mean, it just monitors the SSL connection, then it does the deep packet inspection of the traffic, etc. Now you see how difficult, because it is an encrypted traffic, okay, you have to do quick decryption and then intercept the traffic and then study this traffic. So, it is a huge amount of work that is involved, okay, in this kind of setup, okay. There is this application proxies. Now, this takes a look at the application, okay, what is happening between two applications. So, this is the layer 7, it monitors the layer 7 traffic. The different types of firewalls that one could deploy in the network. The enterprise class firewalls, okay, usually are standalone devices, okay, and they can provide lot of features like VPN tunneling, okay, virtual private network tunneling, it can provide DHCP, it can provide NAT facilities, it can do load balancing, because performance is one of the important criteria with respect to firewalls, okay. So, fault tolerance and load balancing will be two features that you expect out of a firewall, because these are supposed to be 99%, 99.999969s on systems. Okay, these firewalls can also do fragmentation and reassembly of packets, because since it works as a proxy, there could be a different packet length on one side of the proxy and different packet length on the other side. So, this guys can do those kind of fragmentation and reassembly of packets. Then you could have something like stateful filtering, okay. So, what when suppose I only want to see what all the states a particular connection goes through, okay, and I do not want this to go through certain number of states. So, I can filter all those states, okay. I can do a event logging and centralized management of firewalls, and then it also includes hardware upgrades, because you have to cope up with the network speed and the data speed that comes. So, any remote access leads to insecurity, but firewalls and other devices actually allow remote access, but you need to be extremely careful when you do this kind of remote access. So, as usual, like other devices, it provides the CLI or SNMP or web interface and some proprietary interfaces. Okay, with it coming down to consumer grade firewalls, they provide much less feature than the enterprise firewall. So, they have NAT, DHCP, and then they have Wi-Fi interface, some kind of packet interface and logging. So, looks I mean it is similar. So, if you remember all these three devices that we have been looking at, firewalls, routers, and all these three devices that we have been looking at, Okay. They all more or less have volatile evidence, they have persistent evidence, and then you can collect remote evidence. Okay. One of the important things that you should do is, see, as a network administrator or a person, you should enable the logs. I mean, many of the time if you forget to enable the logs, you are not going to collect any more evidence. So, firewall evidence is important. So, here is a typical interface that you can get. So, this is a Cisco interface. Okay. So, CLI for ASA 5505. So, here is something like, I mean, it tells you what is the version and all that. So, it show clock, show version. So, all these are evidences that you can collect. Okay. So, if you look at this evidence, it tells you how much time this was up, okay, what was the startup configuration that it used, and then what is the image file it has, and what is the boot code, where is the boot code, what are the external interface, internal interface, and so on. Okay. Then it also shows something like what is the running configuration. So, what are all the VLANs. So, if you see the inside network, you can see the outside network, what is the IP address of the demilitarized zone, and where is this VLAN connected, and all those things. So, you see all these addresses. Okay. And this is a typical web interface. So, it shows I mean, what is the device dashboard, then you can have the firewall dashboard, etc. So, what are all the tunnels. So, you look at this traffic status and all that. I mean, it is just to see, I mean, as I told you, there is a big screen that you will have to monitor all this. Then it can also, if you can find out what are all the logging. Okay. So, if you say show logging, it says that the timestamp logging is enabled, the standby logging is enabled, okay, console logging is there. So, all these logs we will be using. Okay. So, if you see, there are so many logs that can come out, okay, and these logs can be gathered for forensic evidence. Okay. There are other types of logs that we will look at. Okay. We will take a look at many of these logs and then how to analyze some of these logs. Say probably we will, for one session we will allocate to analyze some logs, look at some logs, and then guess what information we are getting out of the logs. Okay, that will be a separate section that we will be having. In general, okay, these are all the types of log you will get. You will get syslog, then remote syslog. I mean, it includes remote logging to a remote system and getting it. Okay. Then you have authentication, authorization, and accounting logs, which basically radius, attacks, and diameter. Okay, you can look at file usage, statistics, okay, console logs, and the logs that you get out of the terminal. Anyway, we will go into the details of all these logs, some of the format of some of these logs, then how to do some forensic analysis based on some of these logs. What we will do now is that we will now look at how to configure a firewall. Okay, some example of how to configure a firewall, or especially using IP tables. So, IP tables, as you know, is a packet filter. So, in the next session we will take a look at how to configure a packet filter. Thank you very much.